Hello, my name is Marcus Bonner, and in this upcoming video, I'm going to be discussing the use of contingency tables and specifically comparing the real estate data that was given. The task, purpose, and outcome. So the task will be to explain what a contingency table is and to compare the real estate data in the form of a contingency table. The purpose will be to demonstrate my knowledge of analyzing data, and the outcome will be to summarize variables of interest in the form of a contingency table. And in this case, the variables of interest will come from the real estate data that was given. So before we move forward, I want to give a definition of a contingency table. So according to the text, page 116, a contingency table is a table used to classify observations according to two identifiable characteristics. So an example that was given from the text was students at a university are classified by gender and by class. So freshmen, sophomores, juniors, and seniors. How many male freshmen are there? How many male sophomores? How many female male juniors and female male seniors? So that would be an example. Before I get into my actual contingency table that I've constructed, I want to preface it with how I came up with this data. And so in the interest of time, I'm just going to briefly describe how I came up with the data. So I took the real estate data, and in order to make my variables of interest and to figure out what I need to compare, I found the median. I'm going to be comparing the house size as well as the township. So I took the median of the house sizes from the real estate data, and that median size was 2,200 square feet. So basically, I constructed my contingency table with houses that were with townships 1, 2, 3, 4, and 5. Houses being the one of the variables. And I constructed my contingency table with houses that had 1, 2, 3, 4, 5 townships that were above the median size, and then also houses with townships 1, 2, 3, 4, 5 that were below the median size of 2,200 square feet. So for this table, I'm showing the relationship. So and all I did once I figured out the median size, I simply had to count to get my points. I had to count to figure out how many houses with one township were above and below. And in this contingency table, that is what's represented. So for houses with one township, 11 were above the actual median size of 2,200 and 4 were below. If you go over to the right, and you'll see the total, the grand total for houses with townships varying from 1 through 5 were 60 were above and 45 were below. There were a total of 105 different houses in my data set that's given from the real estate data. So those numbers add up, and as well as the total if you were to do it from the columns or if you do it from the rows, they both add up to 105. There were 105 different variables. 105 different data, raw data that was given in the real estate data. So basically, an explanation of my contingency table. So for the houses with one township, there were 11 that were out of 15 that were above. This is for with one township, there were 11 out of 15, or 73%, that were above the actual median size. The houses with two townships, 14 out of 20, so that would be 70%. For three townships, 13 out of 25 equals 52%. 14 out of 29 were 48%, and 8 out of 16 that were above the median size, were 50%. Conversely, you can do the same to find out the below price. So in conclusion, we talked about what a contingency table was, and I compared the real estate data to come up with the comparison of contingency tables for townships with the house size. Thank you for your time, and enjoy the rest of your day.